All right, guys, here we go. So, I would like to know what the sine of 2 theta is. Well, we do have a new identity that goes, that's 2 times the sine of theta times the cosine of theta. Okay, now notice what's going on there. That's the regular angle, and that's the regular angle. So when I'm looking for sine of twice the angle, I use these two. So just for example, if this was the sine of 60 degrees, all right, that's 2 times 30, right? 60 degrees is 2 times 30. So this would be 2 times the sine of 30 times the cosine of 30 if I wanted the sine of 60 degrees. That's how it works. So I've got the sine of theta is 3/5. Now it's a 3, 4, 5 triangle, so we like that. It's easy to solve. And this is pi over 2 to pi. Isn't that the second quadrant, right? From pi over 2, my paper's bouncing on me there. From pi over 2 down to pi, that's the second quadrant. So we draw a triangle in the second quadrant. Always connect to the origin and connect to the x-axis. And so there's my theta in the second quadrant. The opposite is 3, and the hypotenuse is 5. Okay, so then a squared plus b squared equals c squared. And we're going to find that this is -4 because it's a 3, 4, 5 triangle, and the x value's got to be negative to get me into that second quadrant. So this is going to be 2 times the sine of theta and the cosine of theta. So it's 2 times whatever the sine of theta is. That was given us to us as 3/5, or you could look at the opposite over the hypotenuse from the triangle if you prefer, and that's 3/5. But now we also need the cosine of theta, and that wasn't given to us, but because we solved the triangle, we can say that it's -4 over 5. Okay, so if the sine is 3/5 of angle theta, well then when I multiply theta by 2, which would get me down here in the bottom of the circle somewhere, that's going to be 2 times 3 is 6, times 4 is -24, over a 1 in the denominator here really, times 5 times 5. It's 24/25. The sine of twice that angle is -24/25. Okay, the cosine of 2 theta. Well, we found out that the cosine is equal to cosine squared theta minus sine squared theta. That's what we derived on the other page. And so I'm going to take the cosine of theta and square it. So what is the cosine of theta? It's -4/5. So guys, this just goes -4/5 squared. That'll be positive 16/25. And I'm going to subtract this, and sine of theta is 3/5, so I'm going to square that one too. That'll be 9/25, right? So here we go. 16/25, that becomes positive when it gets squared. There's a minus sign there, and 9/25. And 16 minus 9/25 is 7/25. So if the sine of theta is 3/5, and theta is in the second quadrant, the cosine of twice that angle apparently would end up being 7/25. Now you could even tell where twice the angle would end up, right? The angle itself is here in the second quadrant. Now look, if I multiply by 2, if you multiply this by 2, you're at pi. And if you multiply this by 2, you're at 2 pi. So basically what I'm saying is the twice the angle has got to be in either the third or fourth quadrant. It's the smallest it could be is this times 2. And the biggest it could be is this times 2. So it's down here somewhere. And look at the values. Cosine is positive and sine is negative. Cosine is positive and sine is negative. Doesn't that tell you that it's got to be in the fourth quadrant? Wherever it is, it's in the fourth quadrant. Just something to think about. Okay, and then the crazy tricky example. We're going to solve this equation. Look at that. Sine of x times cosine of x is equal to -1/2. Just think about that for a second and think if there's anything you would think to do to solve that equation. Go ahead, take a look. Yep, that's some first period awkward silence right there. You want to see something tricky? I've got sine of x, I've got cosine of x. If I have a 2, I can rewrite it. 2 sine cosine, I could rewrite it like that. And there's a 2. So I'm going to multiply both sides of this equation by 2. That's what I'm going to do. And look, I get 2 sine of x cosine of x is equal to -1. And now I'm looking for all of these from 0 to 2 pi. So one trip around the circle. I want every angle that makes this true. So I can rewrite this because that is the identity. So look, that's the same as saying the sine of 2 theta. Oops, I wrote it wrong. I'm so dumb. Sine of 2 theta is -1. I'm going to rewrite that because my handwriting is that bad. Okay, and I'm looking for all of them from 0 to 2 pi. So we've played the rest of this game before. You've solved this before. So where is 2 theta, where's the sine of an angle equal to -1? Sine is the y value, so that -1 is down here. So I'm going to say that 2 theta is equal to 3 pi over 2 plus 2 pi k is how I start these crazy problems off. And then I'm going to divide by 2, and then I'm going to put in k equals 0, k equals 1, k equals 2, and I'm going to keep going until I find angles that are too big. Okay, when you divide everything by 2, this is what you get. Theta is equal to 3 pi over 4 plus pi times k. Okay, now let's go find which answers actually land in between 0 and 2 pi. So when I put k equals 0 in, there's no math to do. I get theta equals 3 pi over 4. That's a legit answer. When I put k equals 1 in, let's see what happens. I get theta equals 3 pi over 4, and then I'm going to add pi. Well, that's like pi over 1, and I need common denominator, so I'm going to multiply by 4 on the top and bottom, and I get theta equals 3 pi over 4 plus 4 pi over 4, and that gives me 7 pi over 4. Now, that is definitely an angle that's between 0 and 2 pi. If I'm counting by pi over 4s, there's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 is the answer I just got. And then 2 times around the circle where 2 pi is, that would be 8 pi over 4. So I'm going to put k equals 2, but I'm pretty sure that that answer is going to be too big because look how close I am to being all the way around the circle. But I'll do it anyway, just to check. I get 3 pi over 4 plus pi times 2. Okay, so that's 3 pi over 4 plus, if that's 2 pi, it's like it's over 1. I got to multiply it by 4, top and bottom, and when I do, I get 8 pi over 4. So adding these together, I get 11 pi over 4, and we've decided that 8 pi over 4 is the biggest they could be, so that is too big. My solution set, as my math lab would put it, is 3 pi over 4 and 7 pi over 4 are my two angles in between 0 and 2 pi that if I put them in here, they multiply them together, I'd equal -1/2. All right, next page. Oh, here we go. Let's just make some new identities for ourselves because, you know, why not? Rewrite the identity for cosine of 2 theta without any cosine function. So I'm going to replace that. Now, what can I replace cosine with? Isn't it the case that cosine squared theta plus sine squared theta is equal to 1? So if I don't want any cosine functions, I'm going to replace that with 1 minus sine squared. So look, it goes like this. Cosine of 2 theta is equal to, instead of cosine, I'm going to call it 1 minus sine squared theta. And then there's another minus sine squared theta that was in the problem in the first place. This cosine turned into these two terms, and that was just there. And so here we go. Cosine of 2 theta could also be written as 1 minus 2 sine squared theta. There's another new identity for you. It can be replaced with 1 minus 2 sine squared theta. Now, here I'm guilty, completely guilty of hitting copy and paste and not fixing things. I meant this one to say no sine functions. That's my bad. So I'm going to do the same trick, guys. Instead of that sine, I want sine to be 1 minus cosine squared. So look how it starts. I have cosine of 2 theta. I got to put something in parentheses here this time. I don't want sine, so I'm going to leave cosine squared the way it is. But then I go minus, and I have to put in parentheses, instead of sine squared, 1 minus cosine squared theta. Okay, that minus is really important now because it's got to get distributed. So this ends up being cosine squared theta minus 1, but plus a cosine squared theta, because that minus also belongs to that minus cosine squared theta. Now look, I got two of these, and they're both positive. So here's my identity. The cosine of 2 theta is equal to 2 cosine squared theta minus 1. So look, you guys, there's 3 different ways to write this. All right, the cosine of 2 theta, I've got 3 different versions of it. It's cosine squared theta minus sine squared theta, or it's 1 minus 2 sine squared theta, or it's 2 cosine squared theta minus 1. 3 different identities for a cosine of 2x. All right, so here we go. Use cosine of 2 theta equals cosine squared minus sine squared to write a new identity for sine squared. I want to get sine squared by itself. I'm going to get sine squared by itself. All right, let's see. What can I do to get sine squared by itself? Oh, I know. I'm going to rewrite this cosine squared. I'm going to rewrite it. So look, I'm going to get cosine of 2 theta. I'm going to rewrite cosine squared as 1 minus sine squared theta. And then there's minus another sine squared theta. So we did this already. That's this trick right here. And so cosine of 2 theta is 1 minus 2 sine squared theta. Okay, and I want to get sine squared theta by itself now. So I'm going to add 2 sine squared theta, and I'm going to subtract cosine of 2 theta. I'm going to move this because I don't like the negative in front of it, basically. So when I add it, I get 2 sine squared theta over here. And if I'm going to move that over, I'm going to subtract it, so it's 1 minus cosine of 2 theta. I just did 2 steps in one, but you guys are good enough with algebra. You should get that. And then if I want sine squared by itself, I got to divide by 2 here, right? So here we go. I'm going to go up here, and I'm going to say cosine of 2 theta is equal to 1 minus cosine of... Well, that's just dumb. Sorry, I'm getting sine squared by itself. Sorry. Sine squared theta is equal to 1 minus the cosine of 2 theta, and it's over 2. So there's an identity just to get sine squared by itself. Seems like this is pointless, but we're going to use some of these to substitute in different things, especially that one that we just did that I screwed up so badly. Okay, now we're going to do this same trick, but we're going to get cosine squared by itself. Okay, so cosine of 2 theta is equal to, I'm going to leave cosine squared theta here, but I'm going to get rid of that and turn it into cosine squared theta also. So it goes minus 1 minus cosine squared theta. So I'm starting this one the same way I started number 2. So I'm going to skip that step and go right to what I know is true, that cosine of 2 theta is actually equal to 2 cosine squared theta minus 1. And what I'm trying to do is get cosine squared by itself. So I'm going to add 1, and I get cosine of 2 theta plus 1 is equal to 2 cosine squared theta. And I'm getting cosine squared by itself, so I'm going to divide by 2. So I'm going to go over here, and I'm going to actually write the correct thing this time. The cosine squared theta is equal to a fraction where I have cosine of 2 theta on top plus 1, and then I'm going to divide by 2. There you go. Now look at this. Use your last 2 answers to write a new identity for tangent squared. Okay, well I'm definitely not gonna go back to this hot mess. Hang on, I'll show it to you on my other notes here. Lost it on the first page. I'm not going to this tangent of 2 thetas, this, and trying to get that tangent squared by itself. No, thank you. I'm not doing that. I'm going to use a different trick, and the different trick goes like this. Tangent squared could be thought of as sine squared theta over cosine squared theta, right? So look, I've got a sine squared theta identity here, and I've got a cosine squared identity here. So let me just write those. Sine squared is 1 minus cosine of 2 theta, and it's all over 2. That's over cosine squared, which is the cosine of 2 theta plus 1, and that's all over 2. Now, you guys have definitely seen enough complex fractions where I don't have to show you flipping and multiplying. You should know that those 2's cancel at this point. And I have tangent squared theta is equal to 1 fraction with a 1 minus cosine of 2 theta in the top and cosine of 2 theta plus 1 in the bottom. Hey, there you go. A whole bunch of new identities, so let's see if there's one more trick we got up our sleeves on the last page. Let's go to the last page. And what are we asked to do here? Oh, establish 2 identities. Okay, I've got to point out how this one is equal to that one. Cosine to the 4th of theta minus sine to the 4th of theta is equal to cosine of 2 theta. Now if I rewrite this, I would think to rewrite it as cosine squared minus sine squared, right? That's from the first page. Let me bring the first page back in here. Cosine of 2 theta is cosine squared minus sine squared. But how am I going to get them to b to the fourth? I would have to square something, right? Why don't we work with this with the biggest exponents and simplify that and see if we can't get there, right? That's my thought process. Now, I'm seeing this kind of like x squared minus 16 is factorable to x plus 4 and x minus 4. It's the square root of both of them, right? So look, I'm going to factor the left side of these parentheses because those are it's the difference of squares. So you take the square root. It's cosine squared theta and it's cosine squared theta. There's a plus and there's a minus, and it'll be sine squared theta and it'll be sine squared theta. Hopefully you guys can read that. Just like this turned into x plus 4 and x minus 4, you take the square root of both of these, right? Square root of that's x, square root of that's 4. Put them in both spots, put a plus and put a minus. Square root of this is x squared, cosine squared. The square root of that is sine squared, so it's the same thing with a plus and a minus. Yeah? Okay, the rest of this is easy. Isn't that equal to 1? Don't we have an identity that goes cosine squared x plus sine squared x is equal to 1? That's the Pythagorean identity right there. So this is 1 times cosine squared theta minus sine squared theta, and that's supposed to equal cosine of 2 theta. Okay, well now we're talking because we're done, aren't we? Isn't cosine of 2 theta equal to cosine squared minus sine squared? Right? So this is just cosine of 2 theta equals cosine of 2 theta. Well, my handwriting's really terrible. Sorry about that, guys. I'm always in such a rush this year. I've lost my edge on handwriting. Okay, the next one. We're supposed to find out how 4 times the sine times the cosine times 1 minus 2 sine squared is equal to the sine of 4u. I know I said work on the complicated side. The only thing I can't do anything with this. That's like 1 over cosecant and 1 over secant. I don't know anything I can do with that, especially with that 4 there. This I could write as cosine squared, right? 1 minus 2 sine squared. We found that out on one of the last pages. I'll bring it in here. 1 minus 2 sine squared, that would be cosine of 2 theta. I could write that cosine of 2 theta, but I don't really see how that's supposed to help. So here's what I'm going to do. I'm going to work on this side because that 4 is bigger than anything we've been working with. Okay, so you ready for this? I'm just going to put an equal sign here, and I'm going to write that this is the sine of 2u plus 2u. I'm going to use a little bit of a trick here. I'm going to change that 4u into 2 angles being added together. Well, what does that do for me? I'm going to use my the sum and difference identities from the other day. It's the sine of the first one times the cosine of the second one plus the cosine of the first one times the sine of the second one. Right? That's how that goes. I'll write it up here. The sine of a plus b. I mean, we used it earlier today. That's the sine of a and the cosine of b, and we keep the plus, and then it would be the cosine of a and the sine of b. All right, that's the sum identity. Well, this would turn into the sine of the first one, so the sine of 2u, times the cosine of the second one, so the cosine of 2u, then the plus stays there. It's the cosine of 2u times the sine of 2u. All right. Now, we have different options. This one, there's only one option for sine of 2u. Looking at my other page, the sine of 2u only turns into one thing, 2 times sine times cosine. So I'm going to rewrite this one right now. 2 times the sine of u times the cosine of u. That's what this turned into. Then the cosine of 2u, I'm just going to leave alone for a second because we have choices for the cosine of 2u. And then, oh God, what do we have here? The cosine of 2u times the sine of 2u. I need more room for this. I'm going to move my equal sign over here, sorry. I have 2 times the sine of u times the cosine of u. And I left this one as cosine of 2u for now. And then I'm going to add to that, let's see, cosine of 2u again, and that's going to be times the sine of 2u. Oh, wait, you guys, honestly, how can you stand, look at what I missed. Look at what I missed. These are the same thing. Here I am working about writing all this stuff out. Aren't these two the exact same thing? Sine of 2u and cosine of 2u. Sine of 2u and cosine of 2u. This is the same thing. Okay, so look, it's 2 times the sine of 2u times the cosine of 2u. It's 2 of them. So just write it once and put a 2 in front of it. Okay, now the sine of 2 has to be written like I wrote it a second ago. So that's 2 times this sine of 2u turns into 2 sine of u cosine of u. Now let's look at the other side here. That 2 times that 2 is going to be 4 sine of u cosine of u. Now the next thing I have is cosine of 2u, and look what I needed to write it as. That's an actual identity we already have. Cosine of 2u, we found out earlier in the show, right here, cosine of 2u, we rewrote this. It is 1 minus 2 sine squared. 1 minus 2 sine squared. So I can take this and write it 1 minus 2 sine squared u, and look what I have. 4 sine of u cosine of u times 1 minus sine squared of u. So I'm going to write it one more time, and then this hot mess is over. Thank God. Wow, I really botched this one up pretty good for you guys. I would re-record, but I'm a no-edit kind of a guy this year, so there you go. Your homework will be on My Math Lab. We have one more half a section to do with section 7.6. Let me flip over the front page here for you. We worked with double angles today. We didn't work with half angles yet, so I got a little work to do with that tomorrow on section 7.6. I won't put a whole lot of questions on My Math Lab, but it's clearly going to be rewriting some things with double angles, and we'll see how it goes. All right, have a good day, everybody.